So, Wally, um, we went through all the drawings you sent us,
Yes.
put some marks. So what I'd like to do first is to check all the marks in order to receive the exact explanation about them, and then we'll fix the scope of supply. We just repeat it to make sure we don't forget anything. Okay?
Yes. Okay.
And let me share my screen to you as well. Yeah, I will show. Can you see my screen?
It is loading.
Yeah, perfect.
There we go. I've got it.
So yeah, let's start from the beginning. Like, what is a piece? Can you see my mouse?
Yes.
What?
PCV 101. So what that is the inlet guide vane controller is normally in a pressure control configuration. So it's even though it is controlling the inlet guide vanes to the turbine, it's actually acting as a pressure control. So it's either controlling downstream pressure, upstream pressure, something along those lines. In your case, I think you're probably going to, I don't know how do you currently control the JT right now?
Just tell me if it's inside this. It's inside the desk. It is inside the whole scope. So we are not about to touch it to buy it.
Well, so if you see there's the an electronic link to the one to the left that says LCP EC101. So that's the local control panel, the on-skid control panel. So the on-skid control panel is what is wired to the inlet guide vane controller. So, but what happens on the left-hand side, that is your DCS system. So normally what happens is we will receive a signal from your DCS that is telling the guide vane controller what to do. So there is some logic internally in the on-skid panel with some limitations and things. For example, it has a speed limiter internally, so it will try to prevent overspeeding of the unit even if the DCS is commanding it to go to a more open position. But normally the DCS would be what is actually controlling the process pressures.
So DCS is a control system, right?
Is your customer your control system?
It's not the expander DCS. Yes, it's ours.
That's exactly it. It's your see, if you look at the legend on the right-hand side of this page. So you see you've got instrument local mount, instrument display, and then you've got the LCP, which is your on-skid control panel, and then right below that is your the customer DCS. So that would be your plant control system.
This one, right?
Yes.
DCS, yeah.
Okay, that's clear. So, will you include gate vane control as a safety device, just to maintain RPMs on the turbine?
Well, there's two parts. There's two parts to the on-skid control panel. So when the guide vanes, when you're first starting the unit, it's normal to have an operator at the local control panel as you're increasing the speed of the unit. So you can put the guide vane control into manual control and control the machine through the on-skid PLC. And then at some point, you can match the output to your DCS output and then switch the panel, the on-skid panel, into remote control. And when it goes into remote control, then the DCS takes over control of the IGV system. So within that, there are still some limits, but basically the output from the DCS is what the output is on the valve itself.
Clear. So it's just what I want to suggest to Konstantin. So you may tune all the loops locally at the local controller, then transfer the control functions to the DCS, and that's it.
Did you get it, Wally?
Yes.
Can you just explain it again? I missed the idea.
Let me explain once again. So you locally can tune all the control loops, all the safety control loops for both inlet gateway and surge valve, and then you just switch to the DCS, and DCS says to the local panel, increase the flow, decrease the flow, but with the safety limits set inside of local panel.
Wally?
Yeah, well, that's correct. And Konstantin, there's not a question there, I guess. So that's the thing.
Just to clarify, just to clarify.
Yeah, it's just my vision of optimal way of controlling the tuning and controlling the unit.
Yes, yeah, no, that's all correct. There's the PID loops for the surge valve and the IGV. All those things are internal to the on-skid panel. So that's it's all controlled through the on-skid panel, but you can switch back and forth from local to remote control as you need for operation.
Okay, yeah, clear. So the only thing I just wanted to know about IGV, it is inside the skid and it's controlled by DCS, which will be supplied. And
yes.
the only thing we need just to transfer some signals, some data from that DCS to our existing DCS.
Yes.
Very good. Thank you. So the next question.
Yep. Да. Один маленький поправка. Local controller — это local controller. DCS — это ваше заводское. Это две большие разницы. Их не надо называть DCS.
Но подождите, а СУТП наша существующая.
СУТП — это DCS. Local controller — это local controller. Вот это два разных понятия. Их не надо путать.
Но
просто они называются так.
Я правильно понял, что в автономном режиме, когда экспандер работает, он управляется локальным контроллером?
Да, и вы просто даете на него сигнал увеличить или уменьшить холод.
Да, окей, я понял. Хорошо, да. Okay, Oля, just okay. Next question. This question mark is for seal gas.
No, that's the oil connection, but it's not. It's not. It's just there's nothing on this page for that connection. That connection, that's just a carryover, basically, from the second page.
Okay, I just will mark it as oil. It is oil connection, okay?
That is the oil connection, yeah.
About the sizes of flanges.
So normally we don't put the process. The PNID that we send you is normally just the what we would call the on-skid portion. So the other things like the flow transmitter, FCV1, the flange connection sizes on the quote-unquote process connections, that we don't show you on this PNID normally. Normally that is part of a larger PNID that shows all the other process valves. So, it shows your JT valve, all those things.
This one?
No, it's your PNID normally has all those on it.
This one?
This one, yes. Well, that's your flow diagram, but it's basically this. I'm sure you have a PNID for that's relates to this one. Yes, that's the one.
Yeah, but the thing is, we don't have it yet. Our engineers will draw it based on PNID provided from your side. That's why just PID, principal PFD. Sorry.
Yes. Yeah, but we normally don't show, like in this drawing here, the check valve, CV1, your V1, V2, the QCV, FCV1, all these different things. We don't normally show those on our PNID. That's normally on the customer's PNID, right? The process flow PNID, the plant one. So ours, that box right there is what we've given you.
The thing what Anatoly proposed to put on this PNID, two valves which will be included in the supply, because they will be operated by local controller as soon as I understood.
Yeah, we can do that. Yeah, that is true. Those will be wired into the local controller. Yeah. So we can add those too if you'd like.
Oh yeah, please. That would be nice. I would draw it like this.
Yes, there you go.
Okay. So then I will erase here. Anatoly, that's what you plan.
Yes. Just everything must be clearly marked. Supplied by PE or supplied by customer. That must be clearly marked. And also operation logics must be also clearly marked because the mathematical ways of the programming is important thing, and I would suggest you, Konstantin, to keep it on the single responsibility source.
On what?
On single source of responsibility.
Yeah. Okay. Agree.
So on the logic end of the surge controller, we have a separate drawing for the logic of the surge controller because it's a little more complicated. So we typically keep the logic portion separate from the PNID, at least on we have the cause and effect, which is for all the on-skid controls, but the surge control we keep separate from the standard cause and effect because it's a bit more complicated to just have on a cause and effect.
Do you have this diagram in kind of CAD soft program? Yeah. Okay, very good. So next question is to mark these lines, like to show what will be in supply.
Yes.
That's for our design engineers, which will be hired recently. So for them to be clearly understood, because they could not communicate like us. So for them that should be very clear. Okay. So the next question is marked yellow. So could you please briefly explain what is that?
That is the thrust balancer. So the thrust balancer it's contained on the skid, and what that is where the X and Y tubing lines are shown connected. If you look above the oil connection on the center of the unit, you can see an X and Y up there. So that is that's delineating which connection goes to which thrust bearing. And how this system works is there's a hydraulic actuator on the valve, and the direct measured thrust pressure is what actuates the hydraulic actuator. It's a self-contained system. So there's no electronic controller, any of those things. It's completely hydraulic. So it's basically the X and Y are just for clarity on the drawing, right? Instead of putting the tubing connections all the way over there. And then, but that's what that is the thrust balancer. So there's a balance piston behind the compressor impeller, and this thrust balancer varies the pressure behind that balance piston to balance the thrust of the rotor.
Does it take the compressor inlet pressure?
So what happens is the balance piston has a range of pressure that it can operate at. When the thrust balancer is wide open, so fully open, then the inlet pressure is the same pressure as the balance piston. So when the thrust balancer is closed, the top of the balance piston has a labyrinth seal, and the compressor wheel tip pressure bleeds across that labyrinth seal and builds pressure in the balance piston. So the maximum pressure that you can have in the balance piston is about 70% of the compressor stage differential. That's the tip pressure of the impeller. So that's your range of balance pressure that you have in the balance piston cavity. So this balancer, it can vent that balance piston pressure from the back wheel to the suction. And that's it. So it's a fully self-contained thing that just, it's a very small amount of flow. That line, the balance piston line, is like a 3/4 inch line. It's a relatively small line.
Just wanted to be sure it's drawn correctly. It takes the gas pressure from the inlet of compressor, not from the outlet. Okay.
It is to the inlet. It actually vents to the suction of the compressor. So the flow is always going to be going back to the suction.
Yeah, I know what you mean. Yeah. Okay. Then the question about the flange size. So would it be possible to mark it here?
Yeah, I can if you want. That's not a big deal.
Thank you. Thank you very much. Yeah. So we'll go next. This drawing, it's for lube oil system.
Yes.
And seal gas supply.
Yes.
So what are these lines marked in yellow?
Those are drain connections.
So it drains.
Yes, casing drains.
Okay, Anatoly.
Explain a lot.
Yes,
that's explain a lot.
it's fine,
Just
yeah,
drain.
okay. Okay, what is B, the letter B on a seal gas supply?
Yes, so this is the normal operating seal gas supply. So the pipe that we're taking, the B is just for clarity. So there's a pipe that connects from the compressor discharge back to the seal gas supply just upstream of the filter. So when you start the machine, it will start with your the seal gas supply on the left-hand side, whatever your startup source is going to be, which is probably going to be inlet gas, regulated inlet gas, right? Then it operates through the differential.
So it's like a line going like this, right?
It's a pipe. Yeah, it's going to be a 3/4. I think I have it as a 1-inch pipe right now. I think it's a 1-inch pipe.
So you just put B letter B just to eliminate the line from the drawing.
Yeah, right? Because what happens when you start having a lot of these. If you put all of these on there, it gets very complicated fairly quickly.
Yeah, you're right.
And it's not very legible. That's the same thing if you look straight below the machine, the letter A. So that's a tubing connection from the expander back wheel pressure. Where that goes is to your seal gas differential pressure regulator, the load on the top of that regulator, which is in the upper left-hand corner. So you see the dome on the top of the PRV 101A?
Here?
To the right.
Here?
There you go. Yep. Right on the top, see the A?
Yeah.
Yeah, so the valve has a diaphragm and spring. It's a mechanical control valve. And there's a load pressure in the top of that regulator, and that is connected to the back wheel pressure. So your seal gas is regulated to a differential pressure above your back wheel pressure.
Okay, no check wells, no nothing on this line, on these two lines, A and B.
Nothing. What's that?
No check valves needed.
There's no logic needed. Yeah.
Just a stupid line, just a 1-inch tubing between 2 points. Nothing more.
So the connection on B, that is 1-inch Schedule 80 pipe.
And
So
this check valve.
that's fully piped, heavy wall pipe and flanged. On A, that's instrument tubing. So that's just 3/8, small diameter stainless steel instrument tubing.
Okay. So did I mark the arrow right in right direction?
Yes.
Okay.
Yes, you did.
Thank you.
Yes. So how the seal system works is that you have a startup seal gas supply when the compressor doesn't have differential. Because if you think about this, that line A, the connection A, right? So that pressure when the machine is not running is going to be slightly higher than your export pressure when you go to start the machine. So we need a startup supply that the pressure that exceeds your export pressure, so that we can supply seal gas to the unit to start the lube oil. So that we can, because it's the seal gas differential is a permissive to start the lube oil pump. So we have a higher pressure, which is likely inlet pressure to your plant, which you're going to have to regulate and filter. And then that is regulated through that PRV 101A, then filtered, and then it enters the unit. So once the machine starts spinning, then you generate compressor differential, you will have enough differential on that line B coming out of the discharge where it will check the check valve on your startup seal gas supply. So once it starts running, then we have an unregulated, there's no regulator on the compressor discharge, and it just goes straight through the filter and back into the unit.
Yeah, copied. So, next question.
Yes.
This pressure regulator, what does it serve for?
So how the lube system is designed, the pumps are significantly oversized. So there's an API criteria for the pump sizing on the minimum flow of the pump, but the minimum flow of the pump is at a bare minimum is 50% more than what the machine will use. That's the API 617 requirement. So this regulator is the differential pressure control regulator. So what it does is downstream of the filter, it bypasses some oil back to the tank to maintain the correct differential pressure across the unit.
Does it operate mechanically?
It is. It's the same kind of a valve with a spring and piston. So you just have to you manually adjust it, and then it's set. And so since it's downstream of the filter, you should basically never have to adjust it, or very, very seldomly. We set it once usually when we commission the unit, and then after that you should basically never have to touch it.
Okay, it's clear. And one more small remarks. So design speed and rated power and all that.
Yes. So that's still a little bit unknown, and the reason for that is because of the we need to finalize the process conditions. So because if you look at the rated speed, did you look at those data sheets that I sent with the low export pressure and high export pressure case?
Yeah, I've seen, but I didn't have time to run the simulation yet.
Yes, no, that's fine. It's just this is the important reason why we need to do that, because if you look at the low export pressure case in particular, you'll see that the operating speed of the unit is much higher than the original data sheet that we sent. So the design of the unit actually didn't really change. It's the same impeller, but we're going to rate the speed higher than what it was, so that it can operate in this other case. So basically, if you look at that, the power and the speed are both higher than what the original case was. So instead of putting the rated power and rated speed, we really need to sort out what those rated cases, that's going to be the rating case. So we need to sort out the specifics of the rated case, and then we'll add the rated power and rated speed on there.
Okay. Yeah, clear. So where else? I slightly changed this principal flow diagram. I just made a mistake putting this arrow otherwise. As soon as I know, it should be like this. So it's recirculate in case of search. Yeah. Then this check valve. This check valve to be installed here instead of in this place. Probably.
It can be, the check valve can be on either side of the surge loop.
But so it's not. Need it? Can we just remove it completely like
No, you need to have the check valve because the reason for the check valve is so that it prevents it prevents reverse rotation of the machine when it trips. So you need to have a check valve there, but it can be on either side of the flow, the surge loop.
Yeah, okay. So I will leave it here.
It really depends what's easier for you for installation.
Yeah.
Many customers, it's not uncommon to bolt the check valve directly onto the flange of the machine. So that it's a quite easy place to install it. So it depends on what you want to do, but that's one possibility.
Yeah. Okay. So yeah, basically for the PNID, that's it. If yeah.
Go back to your sheet 3 that you have there.
Yeah. Mm-hmm.
So I do think your seal gas source is going to be an issue there because you have it currently connected to the export pressure.
Yeah.
But for startup, that's not going to be a high enough pressure.
But for the startup, there will be this startup source, right? It's this line.
Ah, I see. You're saying that your arrow going down in here is a startup source, which is going to be from somewhere else. Yeah.
A4. It's a vessel here upstream. Yeah.
Yes.
From
yes.
A4.
Yes. So maybe you want to change your red box. Then move your red box so that the seal gas regulator and the check valve that you're showing there is that's on skid. There you go.
And this line, this line's supposed to be
that's on skid as well. Yeah.
So it's here.
Yes.
Mm-hmm. Yeah, cool.
That's the line BB on the PNID.
Mm-hmm. Yeah. Okay. Very good. So. Yeah,
you move check valve directly to the flanges of compressor.
Anatoly did not see our picture, so I will explain him briefly. Анатолий, короче, сам по себе чек-валв номер 2, он не нужен прямо рядом с компрессором, но он нужен, поэтому мы его сдвинули ближе к экспортной линии. Дальше мы саму зелененькую вот эту подачу газа на стартап внутри квадратненького этого, потом увидите. То есть, чтобы было понятно, что будет в поставке. Ну, потом покажу. Тут не сильно поменялось.
Понятно. Да, понятно. Просто пришлите мне конечные.
Конечно, да. Рассылка будет после. Я сделаю. Okay. So, PNID fine. For the explosion proof box, I did not see any updates, so
I think I was still waiting for the picture. I never got the picture of the sticker that you guys need to have on the existing panel the way we've quoted it, which I think sounded like it would be the easiest way to go, but if I need to see what that would look like first.
So Anatoly, it's on your side, yeah.
Yes, I'm waiting for that kind of picture from our supplier of this cabinet.
Yeah.
Yes.
It's just a matter of a day, of 1 day.
Okay. Yeah, no problem.
So for the PSV valves, here is written 550 on the lube oil. Anatoly, today we checked the 2 pressures. Did you send it to Wally? Анатолий, сегодня проверяли, да, 2 давления.
table of weights?
Два давления настройки с ППК спрашивали вот эти.
А мы это решили вроде бы.
Вот здесь мы написали.
Начало открытия и конец открытия?
Да,
или что?
да.
Ну, у них сет прессы это начало открытия.
Не, сейчас по-другому, я у Оли спрошу. Оля, did you see this table? Did you see this
I
table?
have not. No.
You haven't.
I can see it, but I hadn't seen it before.
Okay, Anatoly, we just figure out what is our PSV set pressure for
Yes.
upstream vessel. It's this one. So it goes. This is the maximum allowable pressure for the expander inlet, and this is for expander out discharge.
Yes.
Did you need this information?
I do need the expander inlet because that's what we will rate the expander casing for.
Yeah.
I had been using 110 bar because we started on the design of the casing already, and I'd been using 110 bar, so I've been using a higher number than that. But we normally don't rate the expander inlet or outlet at a different pressure.
Yeah.
So they're rated at the same. We rate the entire casing the same. So the entire thing's rated at a high pressure.
Yeah. Okay.
Okay.
Very good. So basically, from my side, that's it.
Okay.
I don't know, Anatoly, do you have something to add?
No, I think we will resolve everything what I'm interested for in this project a little bit later. And it's just for my education, so I would not spend your time
Yeah.
here.
Yeah, just this kind of meeting just for us. It's a little update, what's going on, what.
Yeah. Yeah.
So as soon as I
That's
as soon as I understood, you're waiting for our simulation cases, which I will provide you, I think, next Monday or next Tuesday.
Yeah, no, that's no problem. We still have, like I mentioned before, we have the casing design and all those things to do first. So the basics of the internals of the machine, the impellers, those things, I don't think any of those sizes are going to change. It's just going to be some of the, the rating speeds and things like that are going to change slightly. So, so before we obviously need the process conditions so that we can finalize the internal design, but that doesn't delay anything on the, on the delivery as long as we have everything to design the casings right now, which is what we've got. So, shouldn't be a problem.
Okay.
And I would prefer not to bother Wally with this bullshit like design of table, of stickers. It's just for information. It would not break any processes of major component design, and I would keep it a little bit later.
Okay, Anatoly, copy it.
Okay.
Yeah, so thank you, Wally.
All right. Well, thank you, guys. Appreciate it. And we'll talk to you soon.
Yeah, fix the Teams application, and we'll talk next time.
Yeah, I'll try to figure out what's going on with that. So at least we have the Skype one working. So we're 50-50 right now on the communication here. So
okay. Have a nice day then. Bye.
Hey, you too. Thank you much. Bye-bye.